So good morning. Thank you all for being here. Today, Tram will be presenting chapter 14, which is on R6 objects, which is probably the type of object I know the least about. So I'm excited to learn more. And with that, you take it away, Tram.
Thanks. Yeah. So I also have not heard of R6 at all. So um, apologies in advance if there's anything that's like unclear or if I'm saying anything wrong, just feel free to, jump in here because this is the first time I'm also seeing this. But so the R6 object is kind of the two defining, I guess, properties about it is that we talked about these methods and generics a couple of sessions ago, but basically the R6 is unique in that it does this encapsulated object oriented programming paradigm where the methods belong to the objects. So you would access them with this like $ strategy here. And another property is that they're mutable. So unlike a lot of different objects in R, which are like copied, these are actually specifically modified in place. So they have their own specific reference semantics. So this makes it like a really unique property of these R6 objects. And these R6 objects are really similar to kind of this base system called reference classes, which I haven't heard of as well, but later on in the section, we'll go through kind of the differences here. But so actually, if you wanted to create like a R6 like class, it actually is through this package R6. And so you have to load it in, but basically just kind of going through the outline here, we'll talk about how to construct it, go through like kind of the key methods that it has. So creating like a new R6 class and then initializing and printing with the R6 class. And then there's also different levels of fields that you can have. So kind of, we'll go through that as well, but there's like private and public active fields. So a lot of kind of, complex ways to make up this R6 class. And finally, we'll go through just like this thing called the initializer, and then what that does. And then there's an initializer and a finalizer for R6 classes, and we'll talk about that. And then finally, the differences between the RC and then R6 very briefly. But yeah, as I mentioned, so R6 classes are created with this R6 package. And so the first thing we want to just talk about is like kind of the reference semantics here. So as I mentioned, like unlike a lot of other R objects, which creates a copy when you make a manipulation to it or something, this actually it falls into the two exceptions of R where it's actually modified in place. So the two exceptions are like when an object has a single binding. This is kind of just review of the, I think the vectors chapter before, but so objects with a single binding are usually modified in place, and then environments as well. So environments are special type of objects that are always modified in place. And so the R6 is actually built on top of environments, and so it's modified in place. And so, yeah, you only need one single function call here, the R6 class, to actually create the R6 object. And the details of how to create one is that the first argument is always the class name. So it says it's not strictly needed, but like generally it's just good practice to do this. And I think people usually, I guess, recommend using this upper camel case to create the names. And then the second argument is what's called like public, which is something that supplies the list of methods. So the methods here you can think of as like the functions that the R6 class actually does, and then the fields. So like basically anything else that you're defining in your R6 class. And then I think these typically are named with snake case. So here is like like a R6 class, like a construction that we can look at. So here, this is the class name, and then there's nothing that says like public in front of it, but this can be assumed that like your second argument is this like public list of your field. And so we have like a sum field here that starts at 0. And then the method, which is like this function within the class. So once again, like this method or function of like adding to your sum, for example. Here you call the sum by doing like self, and then basically $, which also returns like the field of the sum here. And then you add whatever you give it in the function here with X. And so you can access this method of add with this $sign here. And then we always want to return this thing called invisible and then self, which I guess returns like a temporary, like invisible copy of the object. So basically whatever manipulation happened in the current state of the R6 class, it'll return it to the self, so we can keep kind of like a log of it. So we can, basically make this R6 class, and then if we like print it, we can kind of just like take a look at what's within this R6 class. So here we have sum starting at 0, and then we have an add function here. And then there are some other kind of like inherent kind of R6 sections that we can look at later. But for now, we can look at how to use the actual R6 class in practice. So we created this accumulator R6 object, which basically just keeps like a running sum of what you add. But to use an R6 class, because you basically are modifying in place, you want to basically like create like a new object whenever you're kind of trying to like work with it. So here you can, each R6 class has this method of like creating a new one here. So we'll just call this like copy like X, which is basically, if you print it, it's the exact same thing. So it's the accumulator class, and then it's like doing what you originally defined as your accumulator R6. And so what we can do, for example, is we know there's a method called add here. So let's say we add should be 0 right now to our sum. So basically we'll just do that and then return the field of the sum here without the parentheses. It's like returning the field here of our sum. So we just added 4. And so we can see here that it's like keeping kind of like modified in place within this object. And then if we print it again, we can see that the sum was updated in our class. And so the fields and the methods in right now are public. So what that means is that basically you can like get or set the value of like this sum. So you basically can just access it like through your R6 class right now. Later we'll talk about like if you want to restrict access to like the fields or methods or something, we can use these private fields, but we'll talk about that later. So here they also talk about this kind of interesting property of like the R6 class, which is called method chaining. So here we'll just do our accumulator function again, our accumulator R6 class again. Basically, you can like just chain a bunch of like you can just use the X that we already had and then just like keep calling the same method and like chain them together and then return the sum at the very end here. So if we did this, we can see that like we had 4 already. If you remember, like it was already updated to 4, and then we're adding 10, and then we're chaining another method to that, adding 10 again, and then returning the sum field here. So now we see 24. And so this is done all in one line, but to make it more readable, we can also like break it down. So I guess if you had something that was kind of like complicated, like a like a workflow that was like adding, subtracting, things like that, you can kind of just chain it all together and then finally return like the output at the very end. And then, yeah, so this is 24, and once again, we can see it's modified in place. So we're adding 10 again, and then another 10, so we get 44 here. So yeah, this is called method chaining, and it's related to kind of like piping through. We can kind of think of it as like piping. There's some other like methods that are really useful and important for the R6 class. So one of them is like initialize here and then print. So they're not required, but they really kind of help the R6 class like be more intuitive and basically just to create a lot more utility from the R6 class. So for example, this initialize, basically we can think of it as like, you know, how we like made a new like R6 copy basically by doing this new and then the accumulator. So then we have an X that is kind of like a copy of the R6 accumulator class. We basically can do that within our R6 class here with initialize. So this will kind of like override the default behavior of like creating like this new method. And so, so for example, here is another R6 object where we like are taking in the name of a person and then their age. And then each time it's like creating a new like entry here where you can give it the name and age again. And then in the initializer, you can also put like validity checks here. And so it gives you a lot more kind of like utility out of your R6 class. So for example, here, for each time you kind of like give it a name and age, it can check whether the name is actually a character vector, and then it has to be just one name, so the length is 1, for example. And then age must always be numeric, and then 1 as well. And then it'll do these checks, and then it'll assign the input of what we put as a name and an age back into the self. So we always want to like put it back into like the R6 class itself. So here's like a way to check. Basically, this is like a validity check here. So age here doesn't work because this is like character vector here. And so this should be numeric, for example. So the initializer works really well in this case where you want to kind of like make sure the user is like checking their inputs. And so this one will work because this is numeric value. Okay, so then we can also, yeah, so I think you can also, if you wanted some more extensive kind of like validation requirements, you can, I guess, use this like validate method as well, but I think they don't go into that much here. But another useful thing is the print method. So this overrides the default kind of like printing behavior. So when we see like what we put for like Hadley, for example, if we just printed it, it kind of gives you like public, kind of like the fields that are in it, things like this, and then it gives you clone and all these things, but maybe this is not really what you want to return to your user at the end. So you can actually override this like default printing by actually like making a much nicer kind of like, okay, name is this, age is this, things like this to actually like print out a nicer looking output. So here, see now we're not getting like clone and all that stuff. We just print exactly what we want the user to kind of see. So this is kind of like a nice functionality to include in your R6 class. Here I'm just basically showing like this is a way to like create like another random person here. We could see like we can access each field again. And the reason we can access these fields is that they're public. We define these as like the name and age is just public fields. So you can actually directly go in and also like override these public fields here as well. So a key point that I think they kind of emphasize is that methods are bound to individual objects. So this is a point for like the R6 class that might like trip us up in the future, is that like, for example, we had like Hadley here before. And if we look back at what this Hadley class was, this was the original Hadley, I guess, class. So this was before we defined any kind of like printing. And so because we like made this original person R6 class before we added any kind of like printing functionality, this original Hadley class will still print like the default kind of like printing format. And there's no like printing method that's associated with it, even though we went back and basically like renamed our print class here. So essentially like if you change your R6 class at all, even if you give it the same name, like and you already assigned it to something, it's basically like linked to that object. And so like the R2, this Hadley 2 actually is taking in our new print function, but the original Hadley like object did not. So we just want to make sure like if something isn't working, or if you know you changed your R6 class, but it's not showing up for some reason, it might be because you need to like recreate the reconstruct your R6 class with this new functionality. So here it's saying there's no relationship between that first Hadley object that we have and then the Hadley 2, which is like the modified with the print method. So it's really important to kind of like just like keep track of like what you're changing here. And yeah, it gets confusing because like, for example, the person R6 class is still called person in the exact Hadley and Hadley 2, but like these were already, there's no relationship between them. Yeah, so we can also, so instead of just kind of like, I guess, like every time you change your R6 class or you add to it or modify it, instead of like creating like a new Hadley or Hadley 2 that's associated with it, you can actually go in and like override and modify the fields in an existing class. So like here we can actually go in using this kind of provided set method as well. So here we have our accumulator. Let me see. Accumulator R6 class. So currently our accumulator object was just printing like the sum, for example. So this doesn't have the add function, but for example, if we wanted to specifically modify an existing R6 class already, you can go in and call this set and then add like a function. So here we're adding the add function right into the accumulator that we already had. So then you can call that R6 class again, and then we can see that it actually modified the R6 class itself. And then you can also inherit behavior from existing classes. So you don't have to like start all over from scratch. You can actually inherit the kind of functionality and the R6 class that was already created, and then just kind of like modify that and add on to that. So for example, this is like a, I guess, accumulator. You can think of it as like accumulator 2.0, like R6 class here, accumulator chatty, which we're just adding like kind of like a print message whenever we add something, for example. And so the way to do this, we don't have to like, define the sum field again. We don't have to like modify like the adding function. We can just like add exactly what we want to it. And so we can just inherit all of the fields and methods that we already had in the original accumulator, and then just, like create like what we want to add. And the important part here is that you do this by doing the super method, and then like adding. Sorry, it's confusing because it's like adding, but then the function's also called add. But you can include this new function here. So this will override kind of like the super implementation of what was in the original add function of the accumulator. So if we looked at this, for example, if we had the accumulator here, this is before we did anything. We had this add, should have this add method of like, oops. Sorry, so let's take this like original accumulator. Make this. And so, yeah, so basically before we could have something. Oh. That's weird. Okay. I guess the function is just printing there. But basically, this like add function before didn't have like we can see like we're printing like adding x into this new function. So basically, like we can see if we create this new like x2 object, if we did this instead of just like what we did before, where we're just like adding and then like printing out like the numbers here, like this is now like adding on like this word, adding to it. So we inherited like the behavior from that, and then we also like made some manipulation to the functions to have some more like nice printing here. And so this add method basically once again overrides that like superclass implementation that we had in the original accumulator parent R6 class, and then we can basically use this super $sign to like override the parent class if we wanted to manipulate the function somehow. So I think so introspection here. So I think I'm trying to see what it's showing here. Oh yeah, so this is basically just showing us that like you can look at the class of each like R6 class, and they should always have like the class name, and then like tell us that it's an R6 object. And then there are also certain fields that we can look at that are just inherently within an R6 class. So if we like printed the names, for example, of this Hadley 2 R6 class, there's always an enclosed environment field. So these are included in all R6 classes, and we will go through them soon. But basically, you should, if you ever want to look at kind of like what's within your R6 class, you can like print like all of the yeah, like the classes here, and then the names of the that are associated with it. So the field, so age, name, and then kind of like the methods that are included in there. Okay, so we could go through the exercises here, for example. So create a bank account R6 class that stores a balance and allows you to deposit and withdraw money, and then create a subclass that throws an error when you attempt to go into overdraft. And then for the third part, create a subclass that allows you to go into overdraft, but basically charges you a fee instead. So taking kind of just like the the structure of like the accumulator, we can start with something like, instead of sum, we can start with like balance, for example. We can name this, give it a class name of bank here. And then deposit, we can think of it as kind of like an add function. So we have like a deposit function now. So we want to do something to the original balance, and so we want to call it with self. So self balance, and then we just add whatever X value we'll put in as a deposit amount. Add that to the balance, and then return that like the current state after you do a deposit with invisible self here. And the same thing can be done with like just the withdrawal method here. So we want to like update our balance here, and then just subtract whatever amount we want to withdraw here, and then return the current state of the R6 class when we do that. So here, let's so we have our bank R6 class, so create that. And then we don't want to like actually go into our like original, like bank R6 class. So let's create like just a new one that's like a copy here, like the X3. Let's just call it X3. And basically we can, for example, call the deposit method and then deposit $10 here, and then return the balance field so that, oops, we could see it down here. So we see now that there's $10 that we have deposited, for example. And we can withdraw, for example, $20. So this, we would expect the balance to get updated, and yeah, it should be like a negative amount of money now. So actually, like, we don't want it to go into overdraft. So like the next part of the question is, okay, we want to like kind of like do a stop function here where we don't allow it to go past the negative mark. So maybe say something like there's an overdraft error. So here, we don't have to start all over. We don't have to like, make a deposit or withdrawal function. We can just inherit what we got from our original bank R6 class here. So inherit that, and then just make a manipulation or an edit to the actual withdrawal function. So maybe add something like, if your balance is less than the amount that you're trying to withdraw, for example, maybe just stop the function and the method and say there's an overdraft error. So because we're basically inheriting what was already within like an R6 class, we can override the original kind of like withdrawal function here, once again with this like super $ method here. So we're overriding it to have this overdraft error. So let's create this new R6 subclass from the bank, original bank R6 class here. I'll just call it X4 here. And so let's see, it should be, we'll start at a balance of 0 again. Let's deposit $100. We should see that. And then withdraw, so should be 90, for example. And if we withdraw way more than what is in there, it should return an error now because we specified that within our withdrawal function. So then we can actually make it even more kind of intricate here. So maybe we do allow them to withdraw, but maybe charge like some type of fee if it goes over that. So here we're just even creating like another tier of like the classes here. So we can start by inheriting our class before. So we're making like an even, I guess, another subclass here. So inheriting all of the like overdraft statements and all that stuff that we had before. And then we can once again change and add to the withdrawal function. So here it's going to just not stop, but it's going to give an error and then take whatever you're trying to withdraw, so minus that amount, but also a $5 fee, for example, here. And then we're going to override that withdrawal again with the super method here. So call it x5. And so let's do this quickly. Yeah, so we have 100, and then say we want to withdraw more than we have. It's going to give like this error. I think it should work. Yeah, so it took the like amount anyways, but then it charged like an extra $5. So it should have been, you know, without the additional fee, it could have been like -10, but now we charge like $5 fee here. So yeah, so I think just basically skip this part, but basically that's kind of how you can take like a parent class and basically do a lot of kind of like inheriting and subclass here. So the second part here is so you want to have a deck of cards. So here they already provided this kind of like, this is cool. I didn't know that R could show this kind of like the spades and all the symbols here, but basically you can create like this deck of cards here manually. And basically the question is asking, create an R6 class where you can just draw cards from the deck using this make a draw method here. And then N will be how many cards you want to draw. And then make another method, reshuffle here, which basically puts all the cards back and then reshuffles from this entire 52 deck. So the first thing we could do here is just make our R6 class called shuffle. You start with just, let's start with like just a field called deck here. So here, because every time we start like the R6 class, we want to start with like a fresh deck here. We can have an initialize function here. So basically, that's just basically saying every time we like start with this, we want to like start with our 52 decks here. So we take our cards variable that were already in there, and then we just assign it to this field here when we start our R6 class. And then we could do reshuffling. So this is just using like the sample function that's already in R here. So here we can see like the sampling is just randomly shuffling the cards. So that's fairly straightforward to have like our reshuffling, just like put the random shuffling back into our deck here and then return it at the current state into self. But then for the drawing, we can do, this is similar to like something like the deposit, where we basically just have our argument be however many cards we want to take out now. We can do something like if you call more than 52 cards, for example, there won't be enough to draw from in the deck. So we can add some validity checks here. So if you're calling more than 52, and that's, or if you're calling more than the length of your what's in your deck, like maybe print a statement that says there's not enough cards to draw from. And what we could do is just basically take, so this is like our deck here, for example. We can just randomly shuffle it and then take the first, say we want to draw 5 cards. We can just take like the random first calls from the first 5 like entries within our current deck, for example. So return like what we're drawing and then put everything back that is not what we drew with this negative sign. So that will take like 6 to 52, for example, and then put it back into the deck here. So let's see how this will work, for example. So here we can like make another instance of it. So this is like Y, for example. We can reshuffle it. So just like shuffle the deck. It should have like some random, yeah, so it should be all kind of out of order with just like random shuffling here. Then we can draw 10 cards, for example. So it's gonna just grab the first 10 entries of that random sampling of our deck. And we can also test, for example, that stop error. So there's not 100 cards, we know that in our deck, so we can just try to draw that amount, but it should print that there's not enough cards remaining. So we can check that our error is working as well. And yeah, you can just keep basically, yeah, like going through your deck and then yeah, reshuffling and then drawing and yeah. So that's how we do that question. So question 3, so why can't you model a bank account or a deck of cards with something like an S3 class? So we can see here, for example, each time we do something like to our balance, each time we withdraw it or we deposit things in it, it's modifying the actual like balance. And so it's more appropriate to use something like a R6 class where you're trying to model something that is like changing in state. So something like an account balance or like a deck of cards where you're taking cards away, putting cards back in. So an R6 class works really well in this case because you're kind of keeping like a running tab of like what's being modified here. So in those instances, like an R6 class would make more sense than something like a S3 where you copy instead of actually modify it directly. So now this is the fourth exercise. So R6 class, you can also use it to do all sorts of things within your environment. So like here, actually changing some like functionality in your R session here. So you can use it to set your time zone and things like this. So this is like if you wanted to like programmatically like set your time zone with like an R6 class, you could. There's already a function in R, this like system time zone that like returns like what your current time zone is, and you can manually like go in and like set it, for example, with this here. So there's a option here like time zone, and then you can enter like whatever time zone you want to add. So I guess this is if you want to see all the time zones that are available, you can do this function as well. So Olson names, I haven't seen that before, but basically there's like all these different options for time zones, and you can actually like go in and manipulate the environment with like an R6 class here. I think I will skip this, but basically, yeah, this is just like a way to set and like get your time zones and work with like the environment here. Yeah, and in the same way, you can also actually like work with your working directory as your environment. So here, like I think most people know like the get and then like set WD functions that are already within R here. So you can actually like put that into an R6 class and have that like be like a way for you to actually like change your environment and set it as well without having to like I guess just like do this. So this is like yeah, just another way to work with like the environments within the R6 class. So why can't you model the time zone or current working directory with something like a S3 class? So the really kind of cool thing about R6 classes is that they're built on top of environments. And so like if you want to change something like your working directory or like something like your system time zones or something, because they're like built on top of these environments, I think like you can actually like manipulate those things in your R6 class. And so yeah, they're built on top of these environments. And the attributes that they have is that they have like the class attributes. Okay, so we talked a lot about like all of this, like kind of like what we call like these public fields, and the public fields and the methods here. But here, if you ever want to kind of make your R6 class more like restrictive and dynamic for your user, you can actually use something called like these private fields as well. And the difference here is that it allows you still to create like fields and methods, like for instance, like a field would be like our sum, and then like our adding function is like the methods, but this is only available within the class and not outside of it. And then the active allows you to use the accessor functions to define dynamic or active fields. So let's go into this because I think it'll make a little bit more sense if we actually like see some examples here. But so you can do the same thing that you did before. So define these like fields and methods. But the only difference here is that if you want them to be private arguments, instead of doing what we did before as like, you know, if you wanted to access your or manipulate your balance, for example, you might say something like self $balance or self $sum, for example, if you want to access that field. But if you want it to actually be a private field, you will now say private $balance, for example. So the difference here is that you cannot access these private fields or methods outside of the class. And so let's just take a look at an example for here. So the person, we'll work with the person like R6 class again. So here, before we had like the name and the age as something that you can just like access publicly outside of the R6 class here. But let's change the name and the age to be private here. So before, so we're changing the name and age into the private field, and then we can print that in our print function as well. But now we see that it's like listed as like age and name are now private. So I think, yeah, it'll help to like maybe just see this. But basically we can create like another Hadley 3 where we have, for example, so we didn't supply an age, so we just have the like name here. So it's printing out Hadley, and then there's no age. So this looks really similar to, you know, like what we've done before, but the difference here is that if you actually tried to access name, it won't return anything for you. So before we had like our original Hadley, for example, this was like public, you could access like Hadley, for example, or age. But here, if you tried to, because we've now set it as like private, we're not able to like access this field anymore outside of the class. So this also means that you can't just like retroactively like input like the age directly straight into like this anymore. So you actually have to go through like the person $new and then do it with this method. So you can imagine like where this might be helpful or beneficial is like if you don't want your user to actually like be able to go in and manipulate like the certain fields like directly, and you just want them to follow kind of like the formatting of your R6 class that you originally defined here. So it's just a way to really kind of like make it as clear as possible what's okay to access, what's okay to like view within your R6 class. So active fields allow you to define components that look like fields from the outside, but are defined with functions like methods. So these are like active bindings. So basically, I was a little confused on this part. So I'll try my best to explain it, but I think it's just like it's looking at like if you actually give it like a value, if there's no value that's given, it will do like it will, for example, here, like randomly take one value from this distribution, for example. So I think it's looking at whether there's like an active binding and then maybe like returning, like doing this function here. So we can make this new, and then we can just return like a random like number here with this function. Yeah. So they're particularly useful in conjunction with private fields because they make it possible to implement components that look like fields from outside, but you can provide all sorts of like additional checks as well. So for example, like something that is helpful here is that you can actually like make an active class here where you look for age, and then if someone tries to, for example, like manipulate the age directly, which is like a private class now, you can like print a stop function here. Or you can add any type of like new like validity checks here. So here, yeah, so here we can do like another example where we have like Hadley 4. So the name and the age are now, as I mentioned, in like these private classes. So actually, wait, this, oh, I see, okay. So these are technically like private classes. So before we saw that we couldn't actually access like the name. It was like returning null. But here, if you actually want the user just to like be able to see it, but not actually like manipulate it themselves, you can still print it so it looks like it's a field, for example, but it won't let you actually like manipulate it. So we can let the user like see all the different fields and like the what looks like a field here, even though it's private, but we can like also print things like if they try to actually manipulate it. So for example, it might do some checks, like if you make the name like a number, it might give the error that we put here that it should be character and length of 1, things like this. So if you actually try to manipulate the age, for example, it'll tell you that it's like read only. So this is like a very useful way to have all sorts of kind of like checks and things like that for your user, but still allow them to kind of like view the different components of your R6 class. So yeah, I think, yeah, I'm just kind of trying all sorts of different things to like to break it. So for example, we also impose that it should just be length of 1. So not letting the user be able to put like 2 names, for example, things like this. So I think something that, yeah, the exercises are super useful to kind of like just see how this all works. For example, so like the first example is like, now let's work with our bank account class again. But basically you want the user to still be able to withdraw and deposit, but you don't want them to, like a real bank account, you don't want to actually like have them go in and manually like manipulate the balance. It should all be done just with their deposits and withdrawals. So for instance, we can now kind of adapt our like bank R6 class to actually have it be private. So the balance will be private now. So once again, like if you make it a private like field here, like the user can't actually just go in and like say like my balance is like $1 million or something like that. Like you actually have to like withdraw and like deposit here, but the user can still like see their balance. So this is what we're doing here. So we can see, yeah, like the balance is no longer accessible because we set it as private. But the user still should be able to, you know, access their balance. It still should print out their balance. So we make this active binding where we have like our balance, and we return it, but if they try to manipulate the balance itself, it'll say this is read only, for example. So let's create this R6 class. So this is this, for example, deposit. We make sure that the user can still the person can still see their balance because they want to keep track of it, but they now can no longer just go in and manipulate the private field itself. So you can't manually edit it anymore, but it's still available for the person to see. This is really useful. For example, in this another case where this might be useful is if you have a password that you don't actually want to have the person view, for example. So all of these are different ways to allow the user to see or not see certain things. So example, you can have something that's a password, and you kind of just want to check that the person has the correct password, but not actually review their password in any case. So we have passwords, the public password, we just set that as a null right now. So we make that private here. So you can't just go in and manually change the password. They actually have to set it, and then we can do something like a check here with a function where you take their password that they enter and then double check that with what was originally in your private password field, and then see if it matches or not, and then let them in or not. So let's take a look at how this works, for example. So you have a password. So this is the password field here. We can see that there's no active bindings to it. So this should not let you see the password field since it's private here. So if you try to actually access their password, it will just return this private null here. So if you wanted to look at it but not manipulate it, you might do the active, but here we don't want to actually let the user view it. So you can have this setting, but once again, so we're setting it to be this is true password, but once again, you're not able to actually see it. So you want to check it. So now it knows that you have set your private field as true password, and then you can just check that true password matches that private field, and yes, it does. And then basically, yeah, this is a way to kind of just make sure the user can access certain things or not, basically. There's just a lot more examples of how to actually just practice this private versus the active bindings. So I think I will skip this. There's just some more stuff to go on, but yeah, I think an important note, it's kind of nice to just see what actually gets inherited, for example. So what happens when you have private fields and methods, and what happens if you inherit those? Can your kind of subclass use all the private fields, things like this. And so this is just kind of an example, but I created, for example, a parent class that has a private field and method. And then you can inherit that parent class, R6 class, and then what can it actually access if you make a subclass of it. And the important thing to note here is that you can't access the fields, but you can access private methods. And I don't know exactly why, but yeah, I guess this is how it works. You can't actually see the fields of your parent class, but yeah, this private method is available for you. So I guess you can use the functionalities, but maybe you don't get access to all the private fields. Yeah, here's just another way to be really sure. I think we kind of went through this already, but just to be really sure of what your your current like R6 classes, because they're not copied, they can actually like, they're using like the same environment here. So for example, you can't just simply make like an accumulator like Y1 object and then like try to make a clone of it with like Y2, for example. So if you had like in other R like objects, you could just do this and then it'll create like two different bindings for you. But in this case, like if you tried to do this, you made like a Y1 and then you tried to like make a clone of it like Y2. If you check like the environment, like I guess like ID of it, they're actually the exact same one. So it's actually like just like two, I guess like two bindings on the same object. So like you can't actually just like create like another clone of it. So you either have to do something like, you know, like this to create like another Y2. You can't simply say like Y1 into that. So there's this this is where they talk about like the clone method. So if you actually wanted to do that, you might do something like clone, and then it'll actually be two different objects here. So yeah, I think just like being really certain with like where your objects are and like what the bindings are to it, I think is a little bit just like takes a little bit more care, because other R objects don't do this. Yeah, so I think that it also is just saying like, because of this kind of like schematic, like it's just really important to kind of like, maybe it's not as like maybe intuitive as other like kind of R like yeah, R objects, where maybe like you have something like you have a list here like X and Y, and then you I guess you do a function here. It says if you just looked at this, like it's pretty intuitive that maybe like you're just manipulating like the Z here, but if you had something like an R6 object, it's not quite as clear. If you just had something like this, like it actually might, because it's modified in place, like it actually might maybe modify like these other I guess classes as well. So we just want to kind of be double checking like when we modify our R6 inputs, I think. Finally, I think we're getting down towards the end here, but so there's this like initializer, but there's also this finalizer, I guess. And so I guess the way this works is that because they get initialized here to actually like clean up the resources that are created by your initializer in your R6 class, like what you could do is have like, I guess like this finalizer that like does cleaning, I guess it like, maybe, yeah, like wraps up any like temporary like connections, I guess, like, or temporary files. So this, I don't know if this worked for me, but basically I think it's just like, it's kind of like the garbage collector after the object has been unbounded or when R exits. So the finalizer can be called anywhere in your R code. Yeah, I think that it's just a way to avoid any kind of like problems when you have like your resources that are initialized. It's kind of like good practice to, I guess, clean it up when you're done with your R6 class. So if you removed, for example, if you created like a new temporary file, you want to remove it, and then I guess like the finalizer will actually like clean it up as well. Yeah, so I think this kind of just goes through that. Here, the important thing to know, I guess, here is that like even if you do this, I guess it's similar to like what we were talking about before. This actually, like if you did something like made like a new connection within your R6 class, just doing something like $new and then creating like two different objects that are bounded to like this new method is like they're going to be like different. I mean, they're going to be the same. So like these are like the same paths. But if you wanted it to like initialize like a new temporary path each time, like you'd actually want to like, for instance, like create a new temporary binding within your initialize instead of just like doing something like this. So I think this is a little bit maybe like more detailed into kind of like how these R6 classes will work with like connections and things like this. But yeah. And then I think these are just the exercises. And so we're at time here, so I'll just like skip these two exercises. But yeah, just to recap, I think these R6 classes are really good for things that are like changing within like a state that's changing. So like yeah, like something like a balance, or like you want to change your working environment, things like that. And there's a lot of different kind of yeah, options for why you might want to use the R6 versus like S3. And so I think it's all just very like dependent on what you're trying to do and like what you want your user to actually like be able to access or not access manually. And then I think if anyone's interested, like I think you can read more about just kind of like the differences between like this RC and then the R6 classes here. But yeah, I think I'll just go ahead and stop it there because we're at time. But yeah, thanks.
Great, great. That was really interesting. It's so weird to me that that how differently they work than any other type of like R object, but it makes sense. Does anyone have any questions for Tram or in general? Okay, well, I know we're over time, so I want to be mindful of that. So I will see you all next week for chapter 15, which is S4 objects, which is probably the most relevant for those of us who do work with Bioconductor. And Marcel, who I could not think of a better person to present that chapter, so Marcel will be presenting that. And thank you one more time to Tram. Thank you for that presentation. It was really excellent. And talk to you all next week. Bye.
Thanks. Bye.
Thanks, Tram.